Kususangpo. Welcome to Bhutan e-learning project. My name is Karma Jigme and today I'll take you all through mathematics lesson for Key Stage 4, that is for classes 9 and 10. Today we'll learn how to find the area of polygons using the standard formula and the trigonometry ratio. Now before we proceed further, it's very important for you to understand what polygon is. So polygon is any two-dimensional shape formed by joining straight lines. Some of the examples of polygons are triangle, which are three-sided shapes, quadrilaterals, which are four-sided shapes such as rectangle, square, parallelogram, rhombus and trapezoid. Pentagon, which is a five-sided shape, hexagon, which is a six-sided shape, heptagon, a seven-sided shape, octagon, eight-sided shape, nonagon, nine-sided shape, decagon, 10-sided shape. And in this lesson, we're going to learn how to find the area of these polygons using the trigonometry ratios and the standard formula. So first of all, let us learn how to find the area of parallelogram. So parallelogram is one of the quadrilaterals. Parallelogram has four sides. So first of all, let us learn how to find the area of a parallelogram. Now let us look at this parallelogram. Now there are two different ways of determining the area of parallelogram, two different formulas to find out the area of parallelogram. And if you look at this parallelogram, the dimensions are A and B. A and B are the dimensions of these dimensions of parallelogram. A represents the shortest side, B represents the bigger side. And the height of the parallelogram is from here till here. Let's say this is the height of the parallelogram. And if you are provided with the dimensions and especially the height of the parallelogram, and if you're asked to determine the area of parallelogram, the formula to find the area of parallelogram is always base times the height of the parallelogram. In short, it can be written as A equals to BH, where base represents, B represents base, H represents the height. For instance, if the larger side or the bigger side is 10 centimeter and if the shorter side is 5 centimeter and the height of the parallelogram, let's say if this is 6 centimeter, and if you're asked to determine the area of this parallelogram, you can use this formula because it has the height, right? So to find the area of parallelogram, since this is 10 centimeter, we know if this is 10 centimeter, we know that this is also 10 centimeter. This is 5 centimeter, so that side will also be 5 centimeter. So since height is constructed from here, 10 centimeter becomes the base. So to determine the area of this parallelogram, the formula is base times the height. So which one is the base? Base is 10 centimeter. So 10 centimeter times what is the height of the parallelogram? It is 6 centimeter. Now you just find out the product. So 10 times 6 gives us 60 centimeter square. So this is how we find the area of parallelogram by using this formula. Now if you carefully look at this parallelogram, dimensions are given. The height of the parallelogram is not given, but the angle between the two sides is provided. So whenever the height of the parallelogram is not provided, you can always use this formula, which is area is equal to A times B times sine x. So in such cases, when height is not mentioned and when angle is mentioned, you must always use the trigonometry ratio. So whenever height is not given, but the angle between the side is given, you can always use the formula A times B times sin x. In short, it can be written as A equals to AB sin x, where A represents the shorter side, B represents the bigger side, x represents the angle between the two sides. For instance, let's say this bigger side is 20 centimeter, this one is shorter side is 5 centimeter, let's say the angle is 30 degree. So if you're asked to determine the area of this parallelogram, if there's angle between the two sides, you can use this formula AB sin x, right? So A equals to, what is the value of A? A is actually the shorter side. What is the shorter side here? It is 5 centimeter. What is the bigger side here? It is 20 centimeter times we have sine x. What is the value? What is x? X is actually the angle. So what is the angle here? It's 30 degree. Press sine 30 in your calculator and it will give us approximately 0.5. 0.5. Now multiply 100 and 0.5. So when you multiply 100 and 0.5, it will give us 50 centimeters square, and that's how we find the area of parallelogram by using the second formula, A times B times sine x. So this is how we find the area of parallelogram when height of the parallelogram is not given and the angle between two sides is provided. Now if you go back to the parallelogram, if I connect the opposite vertices of the parallelogram with the help of a straight line, this straight line is called as diagonal line. This diagonal line divides the parallelogram into two. Congruent means same, right? So therefore, the triangle, area of triangle is half of the parallelogram. Area of triangle is half of the area of parallelogram. So to find the area of a triangle, we know that when you draw a diagonal line or when you join the opposite vertices, that diagonal line divides the parallelogram into two equal triangles, and we know that area of triangle will definitely be half of the area of parallelogram. So from the area of parallelogram, let us derive the area of triangle. So area of triangle is equal to, what is the area of parallelogram? It's base times the height when height is provided. And we know that area of triangle will be the area of triangle is half of the area of parallelogram. So you just divide by 2. What is this? This is the area of parallelogram. We know that area of triangle is half of the area of parallelogram. So divide by 2. This is when height is provided. Now if you look at this triangle, if height is not provided, now let's say we have these sides. If height is not provided, what is the area of parallelogram when height is not given and when angle is given between the sides? It is AB sine x. This is the area of parallelogram. Now we are finding the area of triangle. We know that it is half of the area of parallelogram. So divide the area of parallelogram by 2, and this becomes the area of triangle when height is not given. So now let us consider one example. Okay, let me draw a triangle. Let's say we have 9 centimeter, we have 8 centimeter, and we have 10 centimeter. And height, remember, height can be constructed from this vertex, height can be constructed from this vertex, height can be constructed from this vertex. Now right now height is constructed from here. So since height is constructed, 10 centimeter becomes the base. If height was constructed from here, then 8 centimeter becomes the base. If height was constructed from here, 9 centimeter becomes the base. So most of us think that this is the base. So this will not be the base. Base can be any of the side. It depends on how you construct the height. So right now, let's say my height is from here, right? And let's say this is the height is 5 centimeter. So my question is, determine the area of this triangle. Now before you actually use the formula, you have to check whether height is given or not, right? So in this case, height is there, the dimensions of the triangle is dimensions are provided. So since height is there, you can directly use this formula. A equals to base times height divided by 2. So area is equal to, what is the base? Base is 10 centimeter. So we have 10 centimeter times, what is the height? Height is 5 centimeter divided by 2. We know that. Now simplify the numerator. So 10 times 5 gives us 50 centimeters square divided by 2. So therefore area equals to 50 divided by 2 gives us 25 centimeter square, and this is the area of triangle using the first formula. Now let us look at another example where the height of the triangle is not provided, but the angle between the sides is provided. So let us consider this example. Okay, we have 10 centimeter, we have 11 centimeter, we have 12. Let's see, we have 5 centimeter and we have 12 centimeter, and the angle here is 30 degree. Okay, let us take this as 30 degree. Now since we have 30 degree here, now height is not given. Since height is not given, since height is not provided, we can determine the area of the triangle using the second formula, which is AB sin x. So area is equal to, what is A? A is the shorter side. Now we have 3 dimensions. So A, now you have to consider this angle. So these are the 2 sides. Which is shorter? 5 centimeters. So we have 5 centimeter times, what is B? It is 10 centimeter times we have sine, what is the value of x? It's 30 degree. So we know that, okay, divide by 2. So area is equal to, so 5 times 10 gives us 50 centimeters square times, what is sine 30? So sine 30 is, using your calculator, so sine 30 would give us approximately 0.5. And you divide this by 2. So therefore area is equal to, simplify the numerator. So 50 times 0.5 gives us 25 centimeters square divided by 2. So therefore the area is 25 divided by 2 is, 25 divided by 2 gives us 12.5 centimeter square, and that's how we determine the area of parallelogram when height of the triangle is not provided. Once again, if I explain, to find the area of triangle, there are 2 different formula. The first formula is base times height divided by 2 when height is given. The second one is AB sin x divided by 2 when height is not given, and when angle between 2 sides is provided. So that's how we find the area of triangle. Let us learn how to find the area of hexagon. Now hexagon is a 6-sided shape. Hexagon is one of the polygons and it is a 6-sided shape. So to find the area of hexagon, remember we are going to find the area of the regular polygons only. When I say regular, when all the sides are equal. We're going to learn how to find the area of regular hexagon, regular heptagon, regular octagon, regular nonagon. So in this class, we're going to learn how to find the area of regular polygons where the sides are equal, where all the sides are equal. Now to find the area of hexagon, as such there is no standard formula to find the area of hexagon. We cannot find the area of hexagon directly. So to find the area of hexagon, we know that this hexagon, from this center point, hexagon can be divided into 6 equal triangles. If the hexagon was a regular hexagon, this hexagon can be divided into 6 congruent triangles. 6 congruent triangles. Find the area of one of the triangles in the hexagon and multiply by 6, because in hexagon, when you divide the hexagon into equal triangles, we get 6 congruent triangles. So you can find the area of one of the triangles and multiply by 6. So therefore, the area of hexagon is 6 times the area of one of the triangles in the hexagon. So what should you do now, right now? So first of all, let us determine the area of one of the triangles. So to find the area of triangle, okay, now just to understand more, let me take out one of the triangles from this one. Okay, so let me make it bigger so that you'll understand it more. So look at this one. Now, for instance, the side of this hexagon, the side of hexagon is 10 centimeter. If the side of the hexagon is 10 centimeter, and if this hexagon is regular one, then if this is 10, the other side will also be 10 centimeter each. So now if this is 10 centimeter, now this will be 10 centimeter because I've taken out the triangle here. Now one thing you need to remember is when you divide the hexagon into 6 congruent triangles, remember the congruent triangles are equilateral triangles. All these triangles are equilateral triangles. In other polygons, in heptagon, in octagon, nonagon, decagon, the congruent triangles will not be equilateral triangle, but except in hexagon, the congruent triangles are equilateral triangle. Now, what is equilateral triangle? Equilateral triangle is a triangle which has all 3 sides same. So, if this is 10 centimeter, the other 2 sides will also be 10 centimeter, 10 centimeter. And in terms of angle, since the triangle is equilateral triangle, we can also predict the angles of the triangle, because it's equilateral triangle. The sum of 3 angles in a triangle is always equivalent to 180 degree. Since all the sides are same, it becomes equilateral triangle, and in equilateral triangle the angles are all 60 degree each. So we have 60 degree here, we have 60 degree here, we have 60 degree here. So 60 plus 60 plus 60 will give us 180. So now you can find the area of triangle, because as I told you before, to find the area of triangle there are 2 different formula, one with height, one without height. So does this triangle have height? So it doesn't have height, it has angle between the 2 sides. So do not go for the formula base times the height, but you have to use the other formula, which is area is equal to AB sine x divided by 2. Divided by 2, because we have the angle, we have the side. So now area of one of the triangles is, what is A? A is the shorter side. In this case, since the triangles are equivalent, both the sides are same. So we have 10 centimeter times 10 centimeter times sine, what is angle? Angle x is 60 degree divided by 2. Once again, if I explain, to find the area of hexagon, there is as such no standard formula. So to find the area of hexagon, since we know how to find the area of triangle, you determine area of one of the triangles and multiply by 6, and that's how we find the area of hexagon. Next, let us learn how to find out the area of a regular pentagon. Regular pentagon. Now, what is a pentagon? Pentagon is a polygon which has 5 sides. Okay, let me draw here. So pentagon is a shape which has 5 sides, and we are talking about the regular pentagon. If it is regular pentagon, all the sides are equal. Now in pentagon, like hexagon, to find the area of pentagon, as such there is no standard formula. So to find the area of pentagon, we know that this pentagon can be divided into 5 congruent triangles, 5 equal triangles. So to find the area of pentagon, like hexagon, you find area of one of the triangles in this pentagon and multiply by 5. Why multiply by 5? Because in pentagon there are 5 equal triangles. So therefore the area of a regular pentagon is equal to 5 times area of one of the triangles in the pentagon. So to find the area of pentagon, first of all, let us determine the area of triangle, and let us consider this example. Let's say the side of the pentagon here is, okay, let us take this as 10 centimeter. If this is regular pentagon, all the sides will be 10 centimeter each. So what is the first step? We need to find out the area of one of the triangles. So just to understand more, let me take out this triangle out and let me make it bigger. Let me make this triangle bigger like this. Now, I've just taken out this triangle out just to understand more. So if this is 10 centimeter, now this side is 10 centimeter. Now, like hexagon, in pentagon, these triangles are of course congruent to each other. They are congruent, they are equal. So that's why we are finding the area of one of the triangles and multiplying by 5. But in pentagon, regular pentagon, these congruent triangles are not equilateral triangle like hexagon. These congruent triangles are actually the isosceles triangle. Now what is isosceles triangle? Isosceles triangle is a triangle where the triangle will have 2 sides equal, when two sides are equal, two other angles are also equal. So in equilateral triangle, all the three sides are same, and it happens only in hexagon. But in other polygons like pentagon, heptagon, octagon, nonagon, decagon, the congruent triangles are not equilateral, but they are isosceles. So let us say, since this is isosceles, now this is 10 centimeter, doesn't mean that we make this as 10 centimeter. Let us assume that these two sides are same. These two sides are same, and this is different. If two sides are same, the two angles in the triangle are also same. So we just know that because it's isosceles triangle, these two sides are same and these two angles are same. Now what we need to do is, can we find the area of the triangle here using any of the formula? No, because to find the area of triangle, first of all we have to check whether there is a height or not. Is height provided? So the height of the triangle is not provided, we cannot use the first formula. And if you cannot use the first formula, you have to see whether there is angle or whether the sides are given or not. So we know these two angles are same, but we don't know the exact angle. What type of angle is this? So we don't know what type of angle, and then sides are also unknown. We just know one of these sides, and angle out of three angles, I think we don't know none of the angles. So therefore we cannot determine the area of triangle using any of the formula. So to find out the area of triangle, you need to either find the height or find the angle or find the side. So what we will do right now here is, now let us try to get this angle. Now to get this angle, we know that, let's go back to this pentagon. We know that when you add these 5 angles in the pentagon, when you add these 5 angles, it will give us 360 degree. And since we need only one of these angle, and we know that sum of these angle is 360 degree, first of all find this one. So what you can do here is, okay, you find out the first angle. So let me write as one angle is equal to, the sum will give us 360 degree. 360 degree, how many equal angles are there? 5. So you write divide by 5. So 360 divided by 5 will give us, okay, so 7 is 35, and we have 2. So we have 72 degree. So therefore this angle is 72 degree now. Now since we got this as 72 degree, we also know that this triangle is isosceles triangles to determine the other two angles, and we know that these two angles will be same. So let us now find out the other two angles. So the other angles, let me write this as other angles. So other angles is equal to, the sum of angles in the three angles is equivalent to 180 degrees. So from 180 degree you subtract 72. So subtract 72 degree, when you subtract 72 degree, subtract by 72 degree, you get 108 degree. So 108 degree should be divided, and these two angles are same, so you divide by 2. When you divide by 2, you get 54 degree. So 54 degree is this angle, and since it is isosceles, this is also 54 degree. Now that we have got all the angles, let us see whether the second formula will work or not. What is the second formula? It's AB sin x. What is A? The shorter side. What is B? The bigger side. What is x? It's the angle. So we have angle here, we have this angle, we have this angle, we have this angle, but doesn't mean that we can use the formula, right? So even though we have this angle, can we use the second formula? Because we have this angle, we have the other side, but we don't know this side. Even if you use this angle, we have value of x, we have the other side, but we don't know this side. So we cannot use the second formula. So therefore, since second formula doesn't work here, even though we know the angles and one of the sides of the triangle, what we will do is, let us see whether the first formula, which is base times height divided by 2, will work or not. So if you are going to use the first formula, we need to have the height. So let us try to get the height. And then just to understand more, let me again take this triangle up. Let me bring this triangle. And let's say our height is somewhere here, because we know this side 10 centimeter. So let us try to construct height from here. What is the side here, it is 10 centimeter. So when you construct height from that vertex, it divides the base into 2 equal halves. So we have 10 centimeter. So now it will divide into 5 centimeter times 5 centimeter. We know that this angle is 54, so this is going to be 54 and this is going to be 54 and that is going to be 72. Now from here, now we need, because we could not use the angle and we could not use the second formula because we didn't know one of the sides of the triangle. We could not use the second formula, which is AB sin x. So that's why that's why we are trying to find out the height so that we can use the first formula to determine the area of one of the triangles. So let's say this is the height. This is our height. Let's say this is our height. And to understand more, again what I will do here is, okay, let me take out this triangle. So when I construct height, it divides this triangle into 2 equal halves. So now let me take out one of the I can see 2 right triangles. Right? Let me take out one of the right triangles. I'm just taking out this right triangle. So we know that this is height. Now the side is actually 10 centimeter. Now I've divided by the height into 2 halves. Now this becomes 5 centimeter. What is the angle? It is 54 degree. So in your previous class, you must have learned how to determine the height or how to determine the sides using the trigonometry ratio. So now we know that this angle is 54 degree. For 54 degree, h, the height is the opposite side and 5 centimeter is the adjacent side. So using this one, angle 54, you determine the height. So we have 54. So opposite divided by adjacent side is the tangent. You can use tan 54 and determine the height. So therefore, we have tan 54 degree equals to, the formula of tan is opposite divided by adjacent side. What is the opposite side? It is height. And what is the adjacent side? It is 5 centimeter. Now using your calculator, find the value of tan 54. So tan 54 would give us around, so tan 54 is approximately 1.377. So use a calculator and get the value of tan 54. So this is approximately 1.377, which is equal to height over 5. Now we know there's 1 here, so do cross multiplication. So height times 1 is height, and then 5 times 1.377. How much do we get? So therefore height is equal to, so we have 5 times 1.377 will give us approximately 6.885. So this is the height now. So this is the height of our triangle. So now what is the height of our triangle now? We got the height. Height of the triangle is approximately 6.885. Now that we got the height of this triangle and we have the base, we can use the first formula, base times the height, not the second formula. Even though we have all the angles, we cannot determine, you know the reason behind. Now we have the height, you have the base, so you can use the first formula to determine area of one of the triangles. Okay, so now to find the area, since there is no space, okay, I'll write it here. So area is equal to base times height divided by 2. So the area of one of the triangles is, what is the base now? Base is 10 centimeter times what is the height? We have calculated the height. Height is 6.885 centimeter. And then since we are finding the area of triangle, you divide by 2. So area is equal to 10 times 6.885 gives us, 68.85 divided by 2 centimeters square. So when you divide this one, you might get 68 divided by 85. So area is equal to 34.425 centimeters. So finally, we could find the area of the triangle. What are we finding? We are finding the area of a pentagon, regular pentagon. So therefore, the area of a regular pentagon is equal to, pentagon has how many congruent triangles? It has 5 congruent triangles, and multiply by area of one of the triangles, which is 34.425 centimeters square, and get the product. So when I multiply this one by 5, I'll be getting 172.125 centimeters square, and this is the area of the regular pentagon when the side of the pentagon is 10 centimeter. So that is how we find the area of pentagon, by finding the area of one of the triangles and multiplying by 5. Next, we learn how to find the area of a regular octagon. So now, as a practice question, I want you to find the area of the other polygons, which are area of regular heptagon. Heptagon is a 7-sided shape, and also I want you to find the area of a 9-sided shape, which is area of nonagon, and finally find the area of decagon, which is a 10-sided shape. I hope you have understood what I have presented today. Thank you, and see you in my next class.